So Sarah Risedorf is a graduate student in the Geological Engineering Department at Montana Tech.
Grab it.
She received her BS in Geology and minor in Chemistry from Fort Lewis College in Durango, Colorado. Sarah worked at the Rocky Mountain Arsenal Superfund site in Denver, Colorado before pursuing her master's degree at Montana Tech. Her thesis has focused on the carbonatite-related REE deposits at Sheep Creek, Montana. Also joining Sarah will be Chris Gammons. Chris is a professor in the Geological Engineering Department at Montana Tech, where he has been since 1997. He holds a BS in Geology from Bates College and a PhD in Geochemistry from Penn State. Between degrees, he worked as an exploration geologist for the Anaconda Minerals Company. Dr. Gammons' teaching and research interests include the study of mineral deposits as well as the environmental geochemistry of mine waste. So the plan for this is, again, dual presentation, and we'll take questions for both presenters at the end of the two. So with that, Sarah, thank you.
Thank you. Hello. Thank you for that introduction. This is my thesis that has been recently defended at Montana Tech. It is new investigations of carbonatite-related niobium REE deposits in southern Ravalli County. The purpose of this study was to further understand the geology and mineralogy of this carbonatite-related REE niobium deposit using modern methods. Disclaimer, this study was funded by the Army Research Laboratory, but all slides in the future will be my thoughts and should not at all reflect the ARL official position. So, what is a carbonatite? A carbonatite is an igneous rock composed of more than 50% carbonate minerals. Also has associated silicate, phosphate, and oxide minerals, and it's normally associated with alkaline rock provinces. This photograph to the left is the Oldungai Lingwai in Tanzania, which is the only active carbonatite in the world. Why do we care? Carbonatites are often associated with lanthanum and associated elements. We use these REE minerals for batteries, magnets, catalysts, and steel alloys. Sheep Creek is located right here, indicated by the red circle. It falls within the Montana-Idaho Alkaline Province. This province trends northwest into the better-known BC Alkaline Province. The yellow stars in this image represent the mineral deposits, and the red, the alkaline igneous deposits. We hope to further study up this trend, starting with Sheep Creek. To zoom in on the regional geology of this area, we see here that the purple is an ogden gneiss metacrystic granite associated rock, while the green is amphibolite and diabase associated rock, and that's where our carbonatite today, number one, will fall. The rocks surrounding this area are mostly belt-age sedimentary rocks, and we are on the west. Sheep Creek is a tributary to the West Fork of the Bitterroot River. The related REE deposits trend southeast and into Idaho and include Mineral Hill, the associated counterpart, Diamond Creek, the Idaho Cobalt Belt, and Lemhi Pass. Zooming in on this one more to the local geology, we can see that the carbonatites, indicated by the red X's, are hosted within the 1.37 billion year meta-igneous complex. This complex has a phyllite age rock suite or a belt age phyllite to the north and tertiary volcanics to the northeast. So far, we have not been able to find carbonatites within these other two rock suites, but they only fall within the meta-igneous complex. Sheep Creek down here is a tributary to the West Fork. Most of the carbonatites we have found have been in this area, but we have also found carbonatites in Beaver Creek and Woods Creek. My data had to do with scouring this area once more because it's been a long time since anyone has been in the region, and finding all of the related carbonatite rocks that we could. We ended up finding 62, 60 of them being in Sheep Creek and one being found in Woods Creek and Beaver Creek. All of these sites have GPS locations, photograph, and representative representative rocks, which we will later apply the modern methods upon. So a little history before we dive in. Sheep Creek was discovered in 1953 when columbite, an iron niobium oxide, was found there. This started the excavation program in 1957, where the company at hand drove 4 adits. During the time that these adits were open, authors like Crowley and Heinrich and Livingston scoured the area, developing some of the first comprehensive articles that we have on the Sheep Creek area, while Abbott, Kaiser, and Anderson were doing the same for the Idaho counterparts on the other side of the border. Mining activities ceased in 1961 with no indication of how much niobium was pulled out of the area. Dick Bird of the MBMG later went back in 1977 to compile a geologic report and map. Gammons, my advisor and the second speaker today, returned to the area in 2018. I started my master's 3 years later, but really what expedited this study was the ARL grant given to Montana Tech to further study REEs in the area. Now, going forward, we used a variation of techniques in order to understand these carbonatites further. First being mapping and sample collection in the first 2 years, optical microscopy and photography. The Terraspect Halo Swear allowed us to analyze a lot of the minerals, or the carbonate minerals, X-ray fluorescence for elemental abundance, X-ray diffraction for the matrix of the carbonatite. We did send out for a whole rock geochemistry testing, and then the SEM EDS with TEMA is what allowed us to further understand the actual REE minerals hosted within these carbonatites. Did get down to Denver, USGS, to do a little IMPA work on the silicates. We also did carbon isotopes and REE osmium H dates for molybdenite. We're currently working on, or we had help working on dates on the monozites as well. So to start off with field mapping, we have 3 primary wall rocks. They consist of a foliated amphibolite, which is composed of hornblende and plagioclase. This is normally where the carbonatite intrudes. These pink indicators are the carbonatite, where the black is the amphibolite. We also have a diabase out there composed primarily of pyroxenes and plagioclase with hornblende actinolite veins streaking through it. These veins are resistant to erosion and often stand out in relief. Lastly, we have an ogden gneiss, whose plagioclase is often rimmed in case bar. This ogden gneiss is foliated at the Sheep Creek site and becomes less foliated and more into a megacrystic granite as we move away from the site. Now the actual carbonatites outcrop like this. It's normally a tan pink weathered color composed primarily of dolomite and calcite. They have a north 70 west trend along the Sheep Creek area and appear as dikes and veins that cut in and out throughout the amphibolite. They can range in width from centimeters to meters and have been as long along strike as 10 meters. When these carbonatites intrude into the amphibolite, they often produce a biotite phenite, which is something we'd like to study more after this. The carbonatites can also be quite folded. They're normally plunging to the east, but their folds are always conformable to the amphibolite wall rock. We are lucky enough that the company USCM that's working out in Sheep Creek right now was able to temporarily open an adit that had been closed since the 60s. You can see the carbonatite, when not heavily weathered, is a lot more vibrant in color. This photograph to the left is a 4-foot horizontal vein underground, and this square here is the enlarged image here. The pink is an ansolite, the black is an allanite, and then this honey-colored mineral is a monazite. The picture on the right is a 1-foot vein vertical vein along the rib of the adit. So what we saw on the surface was dikes that are strung out and appear in pods along the saddles. So what we saw underground was quite exciting, as it was continuous veins of pretty big size. When we cut the rocks open, this is what they looked like. Picture A, you can see allanite, the black bands on top, and bastnasite, the pink underneath. In between this is barite and apatite, the white and tan. We also saw some columbite. That's a 3-centimeter columbite sitting in a dolomite matrix. Monazite was also another prominent mineral in the Sheep Creek field. This is a picture of it in cut slab, and then the picture on the right is what it looks like in hand sample. Upon our preliminary findings, we found with XRF and Halo that the most common matrix minerals were calcite, dolomite, quartz, barite, apatite, and magnetite within the matrix. Now, along the border of the carbonatite to the wall rocks were these more interesting minerals: actinolite, phlogopite, and calcium, a barium feldspar. The most common REE minerals are allanite, a silicate, ansolite, a carbonate, bastnasite, a fluorocarbonate, monazite, a phosphate, and columbite, the niobium oxide. So as we can see, we have a fair amount of elements going through the Sheep Creek deposit enrichment. We also had sparse sulfides, which was good because the molybdenite here is what allowed us to do the rhenium osmium testing that we did. Going forward, we wanted to look at the matrix rocks individually from the REE minerals. And we found that upon all our represented areas, the most common minerals were dolomite, apatite, and calcite. These carbonatites exist in a dolomite-rich end member, a calcite-rich end member, and anywhere in between. They are no more than 20% apatite. Going further into the REE minerals, a little more exciting, we use the TEMA SEM. This produces a false-colored mineral map of the entire sample. The time of analysis depends on the pixel size. So for my images, you'll see here, I have a micron pixel spacing of 5 to 15. These mineral maps also allowed us to further examine each specific mineral map in areas of interest. They look like this. The 4 slides are on the right, and the 3 polished plugs are on, 3 polished plugs are on the right, and the 4 slides are on the left. We don't have time to dive into each one of these slides, so I'm going to show you the most prominent. The first is an example from Crowley. He labeled it blue marble. It was thought that these carbonatites were sedimentary when they were there in the 60s. This is composed primarily of dolomite and calcite, but has medium grain, apatite, and coarse grain clinochlor and magnetite. What we don't see here is many REE minerals. So what we did is went into this slide with BSE imaging. The BSE imaging shows that we have abundant apatite grains with a preferred orientation. We do have late calcite cutting the dolomite, one of our first indications of the paragenesis of the area. Very weak mineralization. What is this rock? So what we have found here is a dud. This is our unmineralized end member of the carbonatite, which is really good to have, but we're not quite sure why we have it yet. So something we're going into. This is what a mineralized carbonatite should look like. If you see here, this orange grain is monazite, and it has inclusions of calcite within it with cross-cutting calcite down here. It is thought to be early because of its size and intrusion pattern. And then we have parasite and bastnasite over here, 2 fluorocarbonatites that show up in these bladed textures. Thought to be late, along with quartz and barite, which are yellow and tan, also thought to be late. Here is SEM of the mineral we saw earlier. Note that we have medium grain, similar size, but we are switching in composition between allanite to bastnasite. So we knew this rock was rich in REEs. Yeah. Oh, sorry. How's that? Better? Sorry, guys. What the more detailed SEM BSE images were allowed to tell us is this first scan. Oh, this first scan. What you see here in blue is noted as an REE silicate. So it was not able to tell us the specifics of what REE silicate this was. So when we went further into the BSE, we can see that this is area 2, blown up here, that our cluster of REE silicates that were not further identified are actually turnoboromite. Turnoboromite is a mineral that has not yet been found in Sheep Creek. And we also found bastnasite, ferriallanite, and syngesite, showing us that even though this seems like a complicated mineral map, when we zoom in to better details, it just gets more complicated. So there, which was awesome to learn in the 18th month of my master's. But very exciting because we're finding these minerals that had not yet been found, and we're figuring out that even what we thought we understood is more complicated. And so we did further analysis on more slabs, and this one we found to be quite interesting. The first photograph, well, here's the slide. The first photograph, area B, is an enlarged area right here. This banded area of the green, yellow, and red is showing the magnetite, calcium, and actinolite. This is a common association of minerals that we seem to find in between the boundary of the carbonatite and the wall rock. That we saw multiple times, so it's cool to see it in such a detailed version of itself. This one down here you can see is a hexagonal relic. It was identified as bastnasite. It very much could be bastnasite, or it could be bastnasite replacing a primary phase burbankite, which is a magmatic mineral and would prove further that this is not a sedimentary rock, but is in fact igneous. Unfortunately, that's just in a hypothesis right now because we did not find any burbankite within the sample. But it also shows monazite, orange, and dolomite blue cutting the burbankite, which is the only example of late-stage dolomite that we've seen so far. When zooming in on this rock, we found more interesting minerals. This is an enlarged BSE image of area 2 here. The first go identified it as 2 minerals, daconschenite and monazite. But when we zoomed in on the area, we found that it is a complex intergrowth of ferriperberite, allanite, allanite and daconschenite over here, and ferriperberite. I said that. So ferriperberite and daconschenite are both minerals previously undiscovered at Sheep Creek. Ferriperberite is similar to allanite but richer in REEs. Check the 3 ceriums. So that's exciting for a metallurgic processing standpoint. And then the daconschenite is a carbonate phosphate only found in China so far. We did it one more time and zoomed in on this area and found 2 interesting minerals, bereaite and shahamalite. Also a complex intergrowth of these REE minerals that are very exciting to the cause. So what I'd like to stress is the complexity of these carbonatites, but also a full list of the REE minerals that we have found so far. 2 indicates Gammons study in 2020. 1 indicates this study with new minerals such as bereaite, daconschenite, ferriallanite, ferriperberite, shahamalite, and turmoborite. These mineral maps also allowed us to put together a paragenesis hypothesis. In this chart, the REE minerals are on top and the niobium minerals are on bottom. The darker color indicates a more prominent abundance than the lighter color. So for REE minerals in the early stages, we saw that monazite and allanite and ferriallanite were the most prominent, later being followed by antallite and parasite. Columbite was the most common early niobium mineral, but due to that niobium mining, where we're not sure how much they took out, I didn't focus on niobium-bearing minerals as much as the REEs. So this is what we saw, but maybe not an accurate representation of what was there before the mining. Next is the gangue minerals periogenesis with the same outline. Dolomite, apatite, phlogopite, and actinolite were the prominent minerals found early. Calcite, barite, and quartz were the prominent minerals found late. As you can see, there are still a lot of question marks, a lot of spaces to fill. We also did geochemistry. We sent out some whole rock geochemistry to ACLab in Ontario. The gray lines are every sample, where the red is the average. We see a steep REE profile that's enriched in light rare earth elements. We also don't see any cerium or europium anomalies. This is typical for carbonatites worldwide, which leans into our discussion of is Sheep Creek a carbonatite? We followed that discussion with a graph comparing Sheep Creek, still in red, to famous carbonatites around the world, including Mountain Pass in blue and Bear Lodge in purple. As you can see, it has a very similar REE profile trend, and sometimes is even more enriched in lanthanum and cerium than some of these other carbonatites. Also with that geochemistry data, we graphed it on a magnesium, calcium, and iron tertiary chart. We saw that primarily the carbonatites are dolomitic, and then they transition to a calcium-rich carbonatite. We were associating later calcite with higher grades of REEs. In order to test this, we graphed calcium over magnesium, the dolomite calcite transition, to the first four and most prominent REE minerals at Sheep Creek. We did see a positive trend towards the calcite side, which could indicate a hydrothermal enrichment or redistribution. We also did carbon and oxygen isotopes, primarily to rule out marine limestone. So if these carbonatites were sedimentary in nature, they would have plotted up here. Instead, the dolomite dominant carbonatites plotted within the primary igneous carbonatite box of Taylor. We do see a trend over here to the more calcite-rich carbonatites. Anderson, 2019, hypothesized that this might be a change in high-temperature exchange with meteoric water, which would also confirm a hydrothermal enrichment in placement. We also had some rusty calcite, just some real oxidized carbonatites that we wanted to check and see if they held true to this trend. They did, plotting on the richer site of delta oxygen 18, most likely through low temperature alteration and oxidation. Lastly, we sent rhenium-osmium dating to Dr. Holly Stein at Area Lab in Colorado. Rhenium-187 decays into osmium-187, and luckily we had molybdenite at Sheep Creek, and rhenium substitutes for the molybdenum. So through this, we could indicate an age date. We set in 2 samples, the first being up here, and we got an interesting age of 147 million years. This is interesting because it does not match any igneous activity in Montana at the time. So we set in a second molybdenite and got 2 ages off of this one to confirm our original late Jurassic stage age, and we got early Cretaceous. So what does that mean? When we were looking at what that could mean, we saw that there's 2 other age reports for this area, one being LAICPMS from UC Santa Barbara, and the other being lead alpha from Jaffe, 1959. But what we see here is a possible association in age dates throughout the year. So maybe this indicates an episodic emplacement of carbonatites throughout the years. We need a lot more age dating to confirm this hypothesis. This is to show the rhenium-osmium dating compared to the meta-igneous complex which it sits in, which was primarily thought to be how the carbonatites originated into Sheep Creek, showing that maybe that's not the case. Rhenium-osmium, according to Holly Stein, is very challenging to reset because of the instability of rhenium. So she has confidence in these H. So now we have to figure out what it means. So in conclusion, this study obtained new mineralogic data for not only the carbonatites, but also the host rocks. Identified several minerals previously unreported from Sheep Creek, acquired new carbon and oxygen isotope values, which show that we're most likely igneous or hydrothermal as opposed to sedimentary, and can also prove that the dolomite is early and the calcite is late. We also observed that these deposits are enriched in light rare earth elements, no obvious cerium or europium anomalies, and the higher grade samples are in the calcite matrix, most likely due to hydrothermal remobilization. And grades at Sheep Creek are similar to Mountain Pass, so when we're thinking about mining in the future. We also have new rhenium-osmium dates that we have to figure out what they're for, what they mean. I'd like to acknowledge ARL, SEM, and TRGS for the financial support, my lab team, my field team, and of course, my academic team. Thank you.
Check, check.
Yeah, of course.
Okay. Great. Great. It was literally 2 weeks ago that Sarah presented this for her thesis defense. So, whoop, too fast. So I'm just going to talk briefly about some of the other ongoing work. Some of you are interested, there is active mineral exploration in the area. There are 2 companies that have the same acronym, USCM. And they're doing the kind of work that you would do, boots on the ground, soil, rock chip, stream sediment geochemistry. I'm not sure. It's been a year since I've been in close contact with them, so I don't know where they're at. Eventually, they'd like to drill, but no drilling has been done to date. And then my own group, Mike, who's actually here, is doing a follow-up thesis. And there's also a lot of funding coming through the USGS to the state surveys in Montana and Idaho to look at this Sheep Creek Mineral Hill, district. Okay. This just shows the claim block. And the 2 companies are overlapping each other here, but basically the whole area has been staked. And these are the 2 companies that if you go on their websites, it's quite confusing because USCM and USCM. But one is critical materials, the other is critical metals. But they're collaborating. This is part of Mike Gary's work and just showing some of the samples that were collected last summer, stream sediment, and what he's doing is doing like Wilfy table and heavy liquid separations to look at indicator minerals in the stream sediment. Things like monazite, which is shown here on the right. We have a X-ray image that is looking at the concentration of cerium in the sample. So all these bright spots are monazites. And then also niobium indicators like columbite. And the idea is like this is a modern day, prospecting, but using an SEM to find out where these carbonatites are. And the Earth MRI investigation, just starting. As I said, the USGS is funding this. They're doing work all over the country, Alaska to the East Coast. And this has been, the Sheep Creek area, Mineral Hill in Idaho has been identified as a priority area. And then they'll be doing a lot of geological mapping at various scales, rock and stream sediment sampling, and getting a lot of geochem, looking for these commodities, and mine dump inventory. And this summer, they'll be flying geophysics over the area. I'll say a little bit more on that. This is not Sheep Creek. This is to the south, but this is the type of information that is collected. This view is roughly 100 kilometers across east-west, so it's regional. But this is a aeromag map, and so we see magnetic high areas. We already think these mag highs are that Ogden gneiss that Sarah mentioned, and then mag lows, which are blue. And so we want to, this is where Sheep Creek is located, right up here, and we want to see features that hopefully show maybe a larger body that's buried. And then this is an example of the USGS airborne radiometric data. So they're looking at not just total counts, radioactive counts, but the counts distributed between potassium, uranium, and thorium. Now we know we have a lot of thorium in the carbonatites at Sheep Creek, mainly in the monazite, but we don't have uranium. And then thorium would be showing up, let's see, as a yellow colors here. And there's kind of a trend here. That's right in the Mineral Hill area to the south of Sheep Creek. So this will be happening. And then just to say that, well, Sarah showed this map, but as academics, we're not trying to find an ore body. We're trying to understand how it all fits together. And so we'll be heading to the north along this trend and looking at other occurrences, hopefully in the next 2 or 3 years. And I think that wraps it up, if there's any questions.
What is the topic of the other thesis?
Mike Gary's thesis is using indicator minerals in stream sediments as a exploration tool to find undiscovered rare earth element deposits. And so far he's been looking only at Sheep Creek, but we're going to go to the north and look for indicator minerals in other areas. I should just point out too that there's been a lot of press releases, but there's no plan to mine there, okay? Because you saw how large the carbonatites are. They're very small. So I'm just saying that nothing's going to be happening for quite a long time on that front.
Doc, could you speak into that microphone if your question?
No, he answered my question.
Okay, great.
Oh,
Are there any age dates for the other carbonatites, like the snowbird?
yeah, Snowbird was dated, I think it's around 71 million years. They dated the parasite there. So that's a bit younger than what we're coming up with. That parasite is pretty strongly metamiced or altered, so that date may or may not be valid.
So it appeared to be a different episode than Sheep Creek.
Right. But like, I'm not a really geochronologist, but now I'm stepping into it, and I realize that one date is never reliable. You got to have many different methods to get the whole story.
I know that rare earth elements are pretty mobile during weathering. So are y'all finding any higher concentrations of these light rare earth elements down gradient from where you're finding the main deposit?
Yeah, that's a good question, whether there is weathering and enrichment in rare earths. We actually don't see a ton of evidence for that. And like these dumps have been there for, since the 60s. Well, that's not very much time, but there's still, plenty of rare earths sitting there. So they're not, it's not like copper, which would get leached out pretty quickly. And we don't see, actually, we're not sure. That's probably on the bucket list to find out, like if there was some vertical drill core and we could compare the mineralogy at the surface compared to down there, that would be the way to sort that out.
Hi, Chris. You kind of touched on a question I had about waste dumps. I was curious about previous mining activity. What's the extent of waste rock, or was there any on-site processing? Are there tailings there? We just saw photos of some outcrops and some underground exposure.
Yeah, the dumps are small. This is the largest of the underground workings. That's 40 feet. So, it goes back a couple hundred feet. And I think they just hand-cobbed the columbite and hauled it out. So there was no processing done on site.
Chris, can you say anything more about the aerial geophysics, the extent of it, who's in it, who's paying for it, and what you expect to get out of it?
Well, it's the USGS Earth MRI program that's setting this up. Now, you may have heard last year they flew the Boulder Batholith. And so most of that was funded through the USGS, taxpayers. But they actually partnered with Rio Tinto Mining Company, who paid for additional, while they were doing that over the main part of the Boulder Batholith, they collected additional data to the south over some areas that Rio Tinto was interested in. And so that additional data will take an extra year to come out, but eventually it will come out. The data that they're going to fly at Sheep Creek and Mineral Hill is completely just public data. It's Earth MRI data flight. So the active companies have nothing to do with this. Okay, thanks.